So over the past several days, we have learned how to find the value of A and how to find the value of B. Today we're going to practice putting the A value and the B value together to make the exponential function. We're going to skip learning target 6, so don't feel like you might have missed something. We're not going to do that. And we're going to go down to learning target 7. So these three tables and these three graphs are the same three tables and the same three graphs that we talked about over here in learning target 4 and learning target 5. So instead of refinding all of the A values and all of the B values, I'm just going to take the work that I already did and put it over here. So if I look at learning target 4, the A values for these three tables are 1, 3, and 1/2 because those are the y-intercepts. So here I'm going to say the A is 1, 3, and 1/2. The A value for my three graphs are 2, 1, and 3 if we look back at learning target 4. So 2, 1, and 3. So value of A is 2, 1, and 3 because those are the y-intercepts. My B values, looking at learning target 5 now, again it's the same three tables and the same three graphs repeated. For the first table, my B value is 2. For my second table, my B value was 1/2. And for my third table, my B value was 3 in learning target 5. So 2, 1/2, and 3. So the 2, 1/2, and 3. Now if I look at the graphs, the B values for these three graphs are 5, 3, and 2. So I will just copy those over here as 5, 3, and 2. So now I have all of my A values and all of my B values that are just taken from learning targets 4 and 5 because we already found them, so we don't need to find them again. Now, learning target 7 talks about writing an exponential function to model a given set of data. We're essentially just taking these values and plugging them in for A and B. Because an exponential function follows this blueprint, you could say, A times B to the x power. So whatever our value is for A, we put that right there, and that's like the starting number. And then whatever the value is for B, what we're multiplying by each time to get to the next number, that goes there. So essentially we're taking our starting number and we're multiplying it by a number however many times we want. That's the x, is however many times. So for our first function to model this table, it would be f of x equals A times B to the x power. 1 times 2 to the x power because that's your A value and that's your B value. For this next one, it would be f of x equals A, which is 3, times B, which is 1/2, to the x power. Now I'm going to put my B value in parentheses. That's actually probably a better way to write it because then it's clear that all of this whole B value is all being taken to the x power. So I'm going to go ahead and do that over here too. That's probably the best way to write it. You'll see it written like that most often with the B value in parentheses. So here we have f of x equals A, my B value in parentheses, to the x power. A times B, so that's A, that's B to the x power. For this one, my function that would create this graph would be f of x equals 2 times 5 to the x power because 2 is my A value and 5 is my B value. The function that would create this graph would be f of x equals the A value times the B value to the x power. And the function that would create this graph with this A and B value is f of x equals A times B to the x power. Remember, that's my A value and that's my B value. So essentially we have, if we look up here, we have this starting place of 1, that's like my A value, and then we're multiplying it by 2 each time. So 1 times 2 times 2 times 2 times 2 to get to the next number. So the 1 tells us where we start, and the b tells us what we're multiplying by each time to get to the next number. So if we wanted to know when x is 3, that would be f of x equals 1 times 2 to the third power, because we would be multiplying 1 by 2 3 times. Essentially, that's like 1 times 2 times 2 times 2, because 2 cubed is 2 times 2 times 2. So that would end up being 1 times 2 times 2 is 4, times 2 again is 8. So f of 3 is 8. Okay, and we can see that in the pattern also, that as we're multiplying down, it's multiplying by 2 each time. It's doubling. So times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, and so on. If we put a 4 up there, we would get the fourth term in our sequence here. So when x is 4, it would end up being 16 because we'd multiply it by another 2. And that is all for writing functions. Have a great day.